SHA-1 works by feeding a message as a bit string of length less than 64 bits and producing a 160-bit hash value known as a message digest. Note that the message below is represented in hexadecimal notation from compactness. There are two methods to encrypt message using SHA-1. Although one of the methods saves the processing of 64 32-bit words, it is more complex and time-consuming to execute, so the simple method is shown in the example below. At the end of the execution, the algorithm outputs blocks of 16 words, where each word is made up of 16 bits, for a total of 256 bits. Suppose the message ABC were to be encoded using SHA-1 with the message ABC in binary being 0110001, 0110010, 011000011, 011000001, 0110010, 011000011, and that in hex being 61, 62, 63, 61, 62, 63. The first step is to initialize 5 random strings of hex characters that will serve as part of the hash function shown in hex. H0 or H0 is equal to 65BE2A01. H1 is equal to BB03E28C. H2 is equal to 011EF1DC. H3 is equal to 9293E9E2. H4 is CDEF23A9. The message is then padded by appending a 1 followed by enough 0s until the message is 448 bits. The length of the message represented by 64 bits is then added to the end, producing a message that is 512 bits. The padded input obtained above M is then divided into 512-bit chunks, and each chunk is divided into 16 32-bit words. W0 up to W15. In the case of ABC, there is only one chunk, as the message is less than 512 bits total. For each chunk, begin the 80 interactions I necessary for hashing. 80 is the determined number for SHA-1, and execute the following steps on each chunk MN. For iteration 16 through 79, where 16 greater than equal to I greater than equal to 79, for the following operation that show in the picture. Now, store the hash values defined in step 1 in the following variables. A is equal to H0, B is equal to H1, C is equal to H2, D is equal to H3, and E is equal to H4. For 80 interactions, where 0 greater than equal to I greater than equal to 79, compute. Temp is equal to S5A plus F I, B, C, D plus E plus W, I plus K is I. See below for the details on the logical function f and on the values of K, I. Reassign the following variables. E is equal to D, D is equal to C is equal to S30 or B is A, and A is 10. Number 7 is store the result of the chunks hash to the overall hash value of all chunks as shown below. The proceed to execute the next chunk. H0 is equal to H0 plus A. H1 is equal to H1 plus B. H2 is equal to H2 plus C. H3 is equal to H3 plus D. H4 is equal to H4 plus E. As a final step, when all the chunks have been processed, the message digest is represented as the 160-bit string comprised of the OR logical operation V as of the 5 hash values. HH is equal to AS128 or H0, V, HS 96 H1, V is S64 H2, V is S32 H3, V is H4. So the string ABC becomes represented by a hash value akin to A999-3E3647-06816, ABA3E25718, 50C26C9C D0 D89D. If the string changed to ABCD, for instance, the hash value would be drastically different, so attackers cannot tell that it is similar to the original message. The hash value for ABCD is 81FE, 8BFE, 87576, C3ECB, 22426, F8E, 5784, 382917 ACF.